All right, question number 1. This says, Chloe practiced playing piano for 3 days. The shaded models below show Chloe's practice times. Each whole circle represents 1 hour. What is Chloe's total practice time? So this problem is asking me to find the total time between 3 different values. That's a pretty good sign that we are going to be using addition to solve our problem. All right, so we have Thursday's time, Friday's time, and Saturday's time here. I'm going to go ahead and label the fractions so I know how much I'm working with. In this first fraction, we have 2 pieces that are colored in out of 3 pieces total. So that means this fraction is 2/3. This middle fraction, we have 1 out of 2 pieces colored. So that is the fraction 1/2. And on this last one, we have 3 out of 4. So that is 3/4. First thing I notice is that these fractions are not all speaking the same language. They all have different denominators, so I need to get them speaking the same language before I can do pretty much anything with them. You have a couple options for doing this. I'm going to do it 2 ways. First, I'm going to use the picture, then I'm going to do standard algorithm. So if I can figure out how to cut each of these circles so they're all in the same number of pieces, then I can find my common denominator. So thinking about the numbers 3, 2, and 4, if we go over here and skip count by these numbers, we should be able to find out what they have in common. So I'm not going to take the time to do that because hopefully you've done it yourself already and you found that they all have the number 12 in common. Whoops. So let's go ahead and work with the number 12. Whoopsie daisies, there we go. All right, so the number 12 is our common denominator. I have to cut each of these circles into 12ths. This circle here is in thirds. If you think about what times 3 equals 12, that's 4. So each of these has to be cut into 4 pieces. Okay, so each of them have been cut into 2 pieces. Now if I cut each of those in half, it should give me 12. All right, so here is 12 pieces, and I can see that I have 1, 2, 3, 4, 5, 6, 7, 8 colored in. So in 12ths, this fraction is 8/12. I'm going to do the same thing over here. This is already cut into 2 pieces, so if I cut each side into 6 more pieces, it will give me 12. Okay, there's 6 on that side. And 6 on that side, and that makes 12. So I see that I have 1, 2, 3, 4, 5, 6 out of the 12 colored in. So 6/12 is the same thing as 1/2. 3/4, there are 4 pieces here, so if I cut each into 3, we will be good to go. All right, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces colored in here. So 9/12 is the same thing as 3/4. Now I can pretty easily add these numbers together. I have a lot of different strategies for doing this. I'm going to show you how to make a whole, which is like our decomposition method first. So here is 8/12. If I wanted to make a whole here, I'd need 4 more 12ths. So I am going to borrow from here. I'm going to decompose 6/12 into 4/12 and 2/12. Okay, and this 4/12 will come right here to make a whole. Okay, so that is 1 whole. And then I just tack on what I have left over. So I've got 9/12 plus 2/12 left over. That is 11/12. So your answer for number 1 is 1 11/12. If you were to do that using standard algorithm, you would get the same answer. Whoopsie daisies. So I know that my common denominator is 12. So how do you get from a 3 to a 12? Well, you multiply by 4, which means I have to do 2 times 4, which is 8. How do you get from a 2 to a 12? Well, you multiply by 6. So I have to multiply by a 6 on the top. And then you have to, how do you get from a 4 to a 12? You multiply by 3. So you have to do a times 3 on top as well. So we ended up with the same 3 fractions on either the standard algorithm or the picture, which means my addition, my sum will be the same also. So if you did not want to do the decomposition method, you could have just added straight across the top. 8 plus 6 is 14, plus 9 is 23 twelfths. Okay, so that is an improper fraction, which is technically okay, but you need to make sure you're paying attention. If you were doing this on a test, if the answer choices were provided to you in mixed numbers, you'd need to be able to convert that. All right, so 23 twelfths. Let's check to make sure that's the same as 1 and 11 twelfths like we got in the last problem. So if you think about 23 twelfths, okay, we could decompose that into 12 twelfths, right? Because the whole point of decomposition is to make a whole. So 12 twelfths, and then how many twelfths would be left over? If you took away 12 of these, how many would be left? Well, there'd be 11 left. Okay, so you can see that we are left with 1 whole and 11 twelfths, just like we were before. So 1 whole and 11 twelfths of an hour. All right, thanks for watching.